So we are looking at redox titrations. We're looking at the second redox titration. It is our red book, page 153, and we're looking at question 7. So as always, we're going to set up our table as attic and basement. We need a volume, a concentration, and a moles. And we are looking for any extra info that's going to be in our question. So in the attic is the KMnO4. So we're scrolling down through to find where it says KMnO4. It's 0.015 molar and it was an average titer of 5.47. So we start these in here. Our mole ratio from our equation is 1. It means the iron then has an equivalent of 5. We are looking for the information on the iron, so it's telling us we had 6 tablets at 4.147 grams. So 6 tablets, 1.47 grams is the mass, and that is in 250 centimeters cubed. It's telling us here that it's 20 centimeters cubed portions were titrated, so we're putting 20 here, and this is going to be our question mark. So the whole point of this is that we're trying to work out the mass of iron, possibly the percentage of iron 2 plus. We are looking for possibly the percentage of iron in a tablet. So it could be in 1 tablet, it could be in 6. Okay, so read your question carefully at the end. So as always, we're going to just go through our W steps. So we're starting, here is going to be our way in, and that is giving us moles in centimeter cubed. When we go down, we divide always, so we're dividing by 1,000 to find out what's in 1 centimeter cubed. When we go up, we're going to multiply by our titer volume, and that is going to give me moles at our end point. We use our ratio at this point to figure out what's the moles in our titer volume on the other side. We have to go down, so again, going down is always a division, and that's going to be by the titer volume to give us what's in 1 centimeter cubed. And finally, we're going up. We're going to multiply this by 1,000 to find out what is in 1,000 centimeters cubed. We then will use our mass triangle to turn it into a mass of iron. Okay, and then we'll worry about the ending. So in terms of the maths, it hasn't changed. So as we've said, this up here is our way in. So I always like to write what this means. So 0.015 big M is 0.015 moles in 1,000 centimeters cubed. We are going to find out what's in 1 centimeter cubed. Sorry. So we're going to divide it by 1,000, and that's going to give us 1.5 by 10 to the minus 5 moles in a centimeter cubed. So we've just gone from here in our W to here in our W. The next bit then is we're going up and we're multiplying by our titer volume, which is 5.47 centimeters cubed. And when we do that, we get 8.205 by 10 to the minus 5 moles. And that is in our titer volume. So at this point, we have to use our ratio because we have gotten up to this point of our W. So we're using our ratio, and the ratio is 1:5. So that means we have to multiply the 8.205 by 10 to the minus 5 by 5 to give us 4.103 by 10 to the minus 4 moles. And that's in our other titer volume in the 20 centimeters cubed. So we've now gone over to this part of our W. We need to find out what's in 1 centimeter cubed. So we are going to divide 4.103 by 10 to the minus 4 by 1,000. And when we do that, it's going to be 4.103 by 10 to the minus 7, and that's moles in a centimetre cubed. That brings us to here, and our last little bit then is we multiply this by 1,000. I did that wrong, didn't I? Yes, I did. So this is not divided by 1,000, it's divided by a tighter volume. So apologies for that. At least we caught it. So divided by 20, it will turn out to be 2.051 by 10 to the minus 5 moles in a centimetre cubed. So apologies for that. And the last bit is we multiply by 1,000. And when I do that, it should go 0.02051 big M. Now, we have a peek at our data table. Technically, there are 3 significant figures here in 5.47, so we turn this into 3 significant figures. So our 3 significant figures are these guys. The one after it here will not do anything to the 5, so our final answer is 0.0205 big M. Now, usually we would be multiplying using our mass triangle, but we're going to go back up and have a little look at our question. So it says we're looking at the part I here. How many moles of KMnO4 were used? So that is our number of moles at our end point, at our tighter volume. So that is going to be this number here, 8.205 by 10 to the minus 5. How many moles of iron 2 sulfate were consumed? So this is after we've used our ratio. So this is the moles of iron 2. This is our MnO4. It then asked, calculate the concentration of iron 2 sulfate in moles per litre, which is this part. And it is also asking us to do it in grams per litre. So we're going to use our mass triangle. Before we do that, we have to do our FeSO4. So we have to work out what is the molar mass of this. So it's going to be 56, it is going to be 32, it is going to be 16 by 4, and when we add all those together, we get 152. So 0.0205 multiplied by 152. When I do this, I'm going to get 3.12 grams per litre of iron sulfate. So that is all the final answer for part I. So we now look at part 2 up here. Calculate the mass of anhydrous iron sulfate in each tablet. So I'm just going to make a note for myself. So we want each tablet. We want to calculate the mass of iron in each tablet. So FeSO4, we want the mass of iron in each tablet. And we also want the percentage of SeO4 in each tablet. So this is our kick now at the end. We have to recognize what it is that we have compared to what it is we started with. So we're looking at our extra info up here, and the extra info that we had is this blurb. So we had 6 tablets in 250. In 250 centimetres cubed, and their total mass was 1.47 grams. So this was our extra info. We've now calculated that we have 3.12 grams in a litre, but we only had 250, so we have to divide that by 4. So 3.12 divided by 4 is going to give me 0.779 grams in 250 centimetre cubed. That is equivalent to 6 tablets. So to find out what 1 tablet is, we need to take 0.779 divided by 6, and when we do that, we get 0.130 grams of iron sulfate. Okay, so that has answered this question up here. The mass of iron sulfate in each tablet. So that's per tablet. We also had to work out the percentage of iron sulfate, so I'm just going to go with that. There are two ways that you can do it. Our total mass was 6 tablets up here, so I'm going to stay with that, and we know that our mass of the iron sulfate is this value, so the percentage of iron sulfate is going to be 0.779 grams all over 1.47 multiplied by 100 over 1. And when I do that, I get 53.0% iron sulfate. So this is one of our answers to part 2. And the last little bit was, so the mass of iron in each tablet. So we have to go back to our moles per litre that we found, which was 0.0205 big M. If we want to find out now how many grams of iron that is, we have to multiply it by the molar mass of iron, which is 56. So I get 1.148 grams in a litre, but we had 250. So again, 1.148 grams divided by 4 will give me 0.287 grams in 250 centimeters cubed, but that is the equivalent, that's 6 tablets worth. So the last thing that I'm going to do is 0.287 divided by 6 will give me 0.0478 grams of iron in a tablet. So that is going to be the final thing that we needed to find out. So there's a little bit of thinking at the very end that you need to see, can you get your head around this extra info that we recorded when we made our data table. That's really, really important. So you need to recognize that 6 tablets was in 250 centimeter cubed. So whatever we're getting for grams per 250 is 6 tablets. We need to then turn that into 1.